You don't sound bad though, Levelist. You can talk. It's fine.
I'll turn him down. It's not as hot as it was.
How you been, bro?
I've been doing good, bro. How about yourself?
Yeah, can't complain. Just got out of the gym.
How's that Vegas weather treating you this time of year?
It's hot.
As balls?
Yep. Yep. Let's see. What is it right now? Las Vegas weather. It is 99 degrees out right now at 7 p.m.
That's it?
Yeah, that's it.
Hey, for someone that is not staying up on top of the latest ether cause isms, that dude that is coming in here with the celestial theodolite, could you give like a couple sentences summary of what's going on with that?
The celestial theodolite?
Yeah, what's he looks like he's putting in a ton of work, and it's like way over my head. Like I don't know how long it would take me to catch up. So
it's pretty much a body bag for the globe, to be honest. So, you know how people like to say, where's your flat earth predictions? Right? So, you have two predictions, right? You got globe math and you got plain trig math. Okay? So FE is just a flat baseline, take an angle, right? Flat baseline. With the globe math, you're basically also accounting for the drop over distance, right? Because it's a curved baseline. So there's going to be two different predictions when it comes to star occlusion times. So imagine you're looking at a mountain, right? And you're able to see stars get occluded by said mountain peak, right? You can use any mountain peak you want. The bigger the distance you are from the mountain peak, the more substantial the difference in prediction will be noticed, right? So like the farther away you are, the difference between flat and globe becomes more apparent, right?
Okay.
That makes sense?
Yeah.
Yeah, the more distance between you and the mountain, the farther the mountain should be below you, below the actual height, essentially. So you're looking at a star, okay? Now, you're waiting for the star to get occluded by the mountain peak. As soon as you see that star disappear, boom. Take the time down, right? Whatever that time is, you mark down the time, then you go to stellarium. You or whatever, star software you want to use, doesn't matter. And then you take the observer location, you put it on that mountain peak because you're basically forcing the line, right? So you're just matching the time between when that star gets physically occluded. So you can't say refraction is involved between you and the mountain peak because the star it disappeared. You can't have something that's you can't see refract, right? It's gone. It's already out of the equation. So what Dr. Mike has done is basically given three predictions, right? And has compared them to the actual measurement of when the star gets occluded. So one prediction is just drop over distance, no refraction. Then you got drop over distance with refraction. And then you have just plain trig FE prediction. And he's basically showing all these measurements in a graph, like in a nice visual graph right now, like the latest one. And it shows that the FE is matching up pretty much within the 1 or 2 arc-minute deviation, while the globe with atmosphere on and off is way off. Sometimes even like 200 seconds off. in terms of arc minutes. Yeah, and so you basically take...
Wait, 1 to 2 arc. You say arc minutes or arc seconds?
So an arc minute is basically 4 seconds in real time.
Okay, so his is saying 1 or 2 arc minutes, and the globe is saying 200.
Yeah, in some cases.
So 100 times off or more. Wow.
In some cases, yeah. If you look at the graphs, it's pretty much a body bag. Like, it really is. Because you can't say it's refract.
And Jesse's the one that's been tasked with trying to refute this evidence.
I mean, they're the only ones that are trying. God bless. But god damn, do they like to waste a lot of time.
Did anybody ever come up with any excuse for why Battle of the Beams is incorrect on a flat Earth? Sounds about right.
That's 2 body bags for the globe, so.
But the sun goes the wrong way in Antarctica.
And?
For 24 hours.
So? You could have a 24-hour sun and still have planar geometry. How? I don't know yet, but it doesn't remove the fact that we live on a plane. It's just irrefutable at this point, especially with the celestial theodolite, dude. It's crazy. Here, I'm gonna send you this highlight reel.
Yeah, you guys need like a clips channel to dumb it down for the fucking layman, because you know it sucks that you guys put on the energy and effort, but you guys are the fucking advanced class. You're like Flat Earth 401, so it's you guys need someone that like relays it to us.
That's my job. I'm the average Joe that can basically boil it down in some aspects. Trust me, I need to boil it down for myself sometimes. But it's pretty simple. It's just basically you have 2 different predictions, right? The timings for the occlusions do not match the globe at all, whatsoever, even with refraction. They actually overshoot with refraction. He uses G.G. Bennett's formula, refraction formula, which is pretty much identical to whatever formula they're using in Stellarium. Like, it's off by like arc seconds, not even. So unless someone wants to bring their own occlusion timings that match the globe, then yeah, it's a straight body bag. And not only that, the implications of it actually show that in order to get their globe, quote unquote, measurements, is they literally have to use flat Earth angles. They have to first get the baseline and then calculate the drop over distance post hoc.
Sounds about right.
What did they? What's the answer though? Because what's confusing to me is if it's 1 degree per 60 nautical miles, how, like, what's the calculation for that from the mountain? Like, don't we have the celestial sphere still? I just don't understand that part of it. Like, because the mountain is closer to this, to the, or whatever, you move in a certain amount of miles, and that will make it off by a certain amount of degrees. So shouldn't the line, when you force it, be at a different angle?
Yeah, so actually, when you do that to Stellarium, when you go into Stellarium and you put the observer on the mountain peak at that same time, you actually have to adjust the azimuth because Stellarium, for some reason, has straight lines curving. So, like, there's the true geometric position of the star. That's all we care about. And that's basically based off a certain time. I gotta ask Alan about it, but it's basically based off the vernal equinox, which is like the first point of Aries, yada yada yada. And it's just it's just about the position in the sky and the time, right? And the true geometric position of the star is all we care about. Not the refracted position of the star, the apparent position. None of that matters. It's all about the true geometric position. So when you take the true geometric position in stellarium into account, it matches the FE like every single time to within like an arc second or two, or an arc minute or two.
Gotcha. Okay.
Yeah, if you see the videos.
Sorry, I was gonna ask a question, but go ahead. Keep going.
No, what was your question?
No, I was gonna say, how would that work in the southern hemisphere if they're all, let's say like 2-3 observers would be pointing in different ways at a star they're seeing. Where would the true position of that star be in that case?
Well, that's why.
Go ahead.
Well, that's why using a physical thing to occlude the star is very important, because you're basically, your refraction is no longer an issue between you and the mountain peak, right? Because if it's behind the mountain, as soon as you can't see it anymore, as soon as it disappears, then you're not worried about refraction, because, you know, it's not refracting if you can't see it anymore. It's just actually being blocked by the mountain. So as soon as you take that time down, you're basically creating a snapshot in time. You compare that snapshot in time to where the true position of the star is, and it matches the flat Earth prediction every time.
Thank you.
Like legit, like it actually is insane.
And no one else has ever done that before, huh? I've never heard of that type of, what are we calling it, experiment or observation?
It's basically a new concept, right? That's why it's called a celestial theodolite. Because, like, you know, the argument about optics has been like nonstop since FE's inception. You know what I mean? It's like, oh, curved visual space. No, that means that's actually Earth curve. Like, okay, how can you prove which one of those things is actually valid, right? What's your referent, right? What is your optical measurement in reference to? You know what I mean? Like, what do you like? How can you actually determine what is mutually exclusive? Well, if you use the stars, like, in comparison to the stars, like using the stars as a referent, now you have something external to basically prove one way or the other. And I think it's actually genius.
Yeah, it makes me wonder what else could be done, what else could be accomplished using a similar observation.
Yeah, absolutely.
Like especially in reference to refraction, right? Isn't that that's going to be their number one? Yeah, it's their bread and butter.
Their saving grace. Yeah. Flat Earth has already won, and it won a long time ago. They basically just kept the zombie corpse of the globe going with refraction. And Dr. Mike comes out of nowhere. Dr. Mike comes out of nowhere and just is like, all right, let's, I want to actually figure this shit out. Because he wasn't a flat earther. You know what I mean? He was just an ether proponent. But he paid attention to, like, all the arguments that we were getting into and was like, I want to actually see if I can, you know, figure this out on my own. He just came up with the concept, just trying to figure it out. He just made 2 predictions and then actually made the observations, the empirical observations, and which one matched? And flat Earth matched, dude. The globe was off. Like, it would basically make the mountain lower than it was supposed to be, which means you would have a different timing. Right?
So
like, the star would be occluded later because it would have to drop lower, if that makes sense.
So now what just popped into my mind is that we need to set up an observation, a commingled observation. We need to grab some globers and see if let's try to set some globers up on some Netflix special type stuff, dude. See if they could prove the globe with this celestial theodolite.
Yeah, so I'll show you. I'm gonna post a little video here.
And then turn it into a
Essentially-
TikTok.
This is actually what you're seeing. Oh damn, it's too big of a video. Here, I'll stream real quick for you, just so you can see like what it is he's actually doing. He just has a sea star from his sky room, like from his house. This one he's looking at Green Mountain. Check it out, Levelist.
Okay, yeah, it wasn't letting me in there. Okay, we're good.
Yeah, do you see? So you're basically just looking at stars. See, it's a star. You're waiting for it to get occluded. Boom, take a snapshot. So you basically just watch. This is just the celestial sphere just rotating. Doesn't look like literally doesn't seem like there's much refraction there. And even Matthew Learns admitted that there wouldn't be much refraction at the top of the mountain either. So you could just bam, whatever star that is, right? You would go to Stellarium, insert your coordinates, and then you can get your bearing by using like mountaintype.com and stuff. So essentially you put in your coordinates and the mountain peaks coordinates, right? And it'll tell your azimuth bearing, right? Like which direction you're facing horizontally compared to the celestial sphere, right? That's your azimuth, 360 degrees around you. You see what I'm saying?
Yeah. So, like with this information, you're basically reverse engineering, or you're figuring out the secrets of Stellarium, essentially. How they're coming up with their numbers.
Any star software, any software that uses the celestial sphere, because it's basically taking the timing. So like this star right here is always going to be right there at that time, no matter what. Depending on where you are on Earth, if you're able to see the star or not is a different question. But in that snapshot of time, like that star is always going to be right there. Might be a little off, like 6 months from now, etc. Because, the ecliptic and all that stuff. But the point is, you're basically just taking that snapshot, right? And going in Stellarium, putting in your initial bearing and your final bearing, and it'll tell you what star that was at that time. So that's why you want to use bright stars, because brighter stars will appear bigger in Stellarium software. And then, bam, take that snapshot, right? And you put in the true position of the star, not the atmosphere turned on refraction stuff, right? That basically will put it up like 15 degrees higher, because you want the true position, and it'll match the FE prediction every time. Literally every time. I mean, just look at this. This is literally, you're just watching stars get occluded. You can't say refraction because you can't see the fucking star anymore. Does that make sense?
Yes, very well said. Thank you.
Yeah. But their only saving grace is refraction. That's actually where they hide the globe. You basically take flat Earth angles to stuff, to the stars, essentially, and calculate using celestial correction tables, depending on what star you're looking at, the location, etc. How high is the star in the sky, like what degree it is, and then basically there's like tables upon tables to calculate the celestial refraction coefficients that you can just insert and basically reify your globe every time. But what Dr. Mike has shown is that they can't even get their predictions without a flat Earth prediction first. That's the cool part. Like, they can't even do it without playing trig in the first place. Here, I'm gonna get you the latest star log. Just open this up in Google Sheets. Yeah, just open up that in Google Sheets. Oh, Daz is not in voice, otherwise I had to answer him. Yeah, watch that little highlight video though.
Yeah, I'm gonna check that out.
Yeah, the crazy part is too, like he shows that what stellarium does when you have the observer to the star instead of the observer to the mountain peak. All you have to do is do 2 times d over r squared instead of 1 times. So 1 times d over r squared is just from you to the mountain. 2 times d over r squared is from you to the star. So imagine you're on a ball, right? And the midpoint between you and the star is the mountain. So you basically have 1 drop over distance calculation, and then you're just basically adding it in again from the mountain peak to the star, because it's twice. The curve would be 2 times that. Does that make sense? So like,
Yeah, that. Go ahead.
yeah, so that is what stellarium actually uses. But it doesn't actually tell you that in stellarium. He figured that out by reverse engineering these predictions.
And where'd this guy come from?
He was basically just following Alan and ether cosmology since like October last year, because he wrote a book called the Ramblings of an Old Man or something like that, and another one about like the luminiferous ether, and actually has his own conceptions and measurements and mathematical formulas to basically explain certain ether phenomena. He used to be in computer science. He has a PhD in computer science, and he used to work. He used to work for some DoD extension. He couldn't even talk about it. I kind of tested him on that. He's legit. He knows about exascale computing and all that stuff, and he was telling me like that's not even the tip of the iceberg, which kind of freaked me out a bit. But
Him and Bennett get along?
oh yeah, oh yeah, for sure. But he's a sweetheart of a guy who runs a dog rescue as well, for a Great Pyrenees. So like,
Oh, big boy dogs.
yeah, he's like 11 of them or 12 of them or something like that. Crazy.
So, Be-Asti-cles, in Vegas, homeless people will
Yeah, that's
stay
cool,
in
man.
the
I just felt
tunnel.
bad not being able to, not having enough time to get in there and figure out what was going on with that.
Is it any better?
Yeah, there you are.
Okay. I was just gonna say he's kind of, I think what he's saying is a horizon can be made of mountains, but then I think you're saying no, he's talking about the horizon that you measure off of, which is not like if you live in like Phoenix and you're surrounded by mountains and that's your horizon, you wouldn't take that as 0 and take angle measurements off of it.
Exactly.
Well, 0 is probably sea level.
Right.
Not really
So the
yeah.
elevation of the mountain is how high the mountain is above sea level, the mountain peak. Correct? So you know it's not 0.
Correct, yes.
Right. So it's not the horizon.
Yeah, but horizon doesn't need to be at sea level.
Yeah, no.
I agree.
I thought you guys were all the horizons where the sky meets the ground, guys.
Yeah, no, that's what he is saying.
I
Like
agree.
you can have a horizon made of mountains, but in this scenario, when you're taking an angle measurement to the mountain, you do it off that 0, which is like, if you're at the beach Even the horizon doesn't fall at that all the time, so I don't know. Yeah, it's kind of a misnomer.
But that's why you're using a mountain peak, because you know that it's a certain number of feet above zero. That's the point.
Which then you could derive your angle by making the triangle and doing SOHCAHTOA, is what you're saying. Yeah, I understand.
Yeah, exactly. Do SOHCAHTOA. You have two predictions. You see what predictions match. That's it. And then that show runs. Okay.
But I'm pretty sure SOHCAHTOA would only work on a flat Earth.
Correct.
You're assuming that that mountain is at a 90 degrees to where you're standing, but on a curved Earth, it would be at a different angle.
Exactly. That's exactly the point of the celestial theodolite, to see which one of those is true.
Okay, yeah, that's a good idea.
You see what I'm saying? So like the occlusion timing, right? The timing in which the star disappears, it'll have one timing for globe, and it'll have another timing for flat. And you just see which one matches. The globe timing has not been substantiated ever in any of these measurements. Like, it's been 39 observations, all different peaks, all different stars, different times. Like, here, I'll take a screenshot of this real quick so you can see. And I'll take another one. It's atmosphere turned on. The one in green is atmosphere turned off, so it's just drop over distance. Atmosphere turned on. It's just to the mountain peak. That's the globe angle. And then you get the flat baseline. I don't know if it's there it is, right here. I got this one. Now, when you see the flat delta, globe delta in column X, in all of those, you'll see how much the deviation is off from the actual timing. In both cases, with atmosphere turned on and off on the globe prediction, it's off by a significant amount.
Oh, well.
Which makes sense. Like, it would have to be lower. Like, let's say it matched the globe. Like, legit, let's say it matched the globe. This would actually be hardcore evidence for the globe side. Like in reality. But it's not. That's how crazy this is, because it basically shows the implications that they built Stellarium and other star, software. I don't know what you call it exactly. I don't know what the term is, but Stellarium, Gaia, whatever you want to use. They basically took trig, plain trig, and then calculated what it would have to be to fit a globe in post. That's the implications of this.
And so your findings align with the flat Earth?
Yeah, dude.
Oh, wow. And is the globalist counter argument to this like refraction?
Yeah, but it doesn't even make sense, because every time we get them to Steelman what the globe prediction would be, it's exactly what Mike says. Like literally, 2 degrees 17 arc minutes, 2 degrees 19 arc minutes with terrestrial refraction. Even if you have terrestrial refraction added in along with celestial refraction, the timing is still off. It's either overshooting or undershooting.
Not to defend the Globers, but I've heard the argument said that the rebuttal is that, well, the Earth isn't a perfect sphere. There's like areas of plateauing. There's like a flattening factor in certain areas. Ironically, even in Stellarium, there's a flattening factor in certain areas.
Yeah, but all that is just rhetoric because of it's just what is the actual timing measurement? Right? Like in reality, when you're observing the stars.
But since it's not a perfect sphere, there's areas of like, you know what a plateau is, right? Like flat.
So it's flat everywhere, locally.
I mean, we think it is.
But I mean, though, like
they will admit that they will admit that there's areas of the Earth that are flat, even though it's a globe.
Well, that's literally been one of the only arguments I've heard is that it's just a cosmic coincidence. It's just a coincidence. So, yeah, celestial theodolite, no good rebuttal from the globe side, and battle of the beams, still no rebuttal.
They can only admit so much to being flat, though. Like, that's the thing. They can't just say wherever we observe it is flat. It's got to match their model.
Like, imagine you had a ball, right? And you just rubbed it down in certain areas so there'd be plateaus on that ball. You know what I'm saying?
Yeah, but now everything has to account for that.
What do you mean everything has? What do you mean by that?
Like, the model's going to have to account for that, right?
Oh, they do. That's why they don't call it an actual sphere. It's a
oblate spheroid
or oblate. Yeah, so an oblate spheroid. What's the other word that they use?
Hold on, real quick. NASA says both have been thoroughly debunked. How so, NASA? Let's back up your claims here.
Sure, the Battle of Beans is well known. I mean, the fact that you refuted and they just disassembled. I mean, on MC Toon, they just thoroughly disassembled line by line the celestial theodolite. Did you watch it or not?
I'm asking you, how has it been thoroughly debunked? I'm asking you personally.
MC Toon's video goes over it line by line.
So you don't even know, you're just saying it, you're just repeating it like a parrot?
Line by line. Did you not watch it?
No, I'm asking you. You just said it's been thoroughly debunked. So how do you know it's thoroughly debunked? Can I get the evidence or the refutation?
Watch the video line by line. It's very,
Wow, great argument.
Yeah, it is actually. If you watch the video, you can see that they go through line by line this spreadsheet, go through the formulas and the way they were adjusted. And
yeah, but how would you know it's a great argument if you don't even know what the argument is?
What did you watch Did you watch the video? If you didn't watch the video, we're arguing from different.
Yeah. So what's the actual argument?
So you didn't watch the video? Yes or no?
I mean, if you don't know what the argument is, then there's no point
it's a simple
talking about
question.
it.
Either yes or no. Did you watch the video? I mean, why?
I mean,
why
the first question. The first question, if we're going to go in order.
No, I didn't watch the video.
Me,
well, thank you. Then you don't know what I'm talking about.
Do you know what the argument
and you should watch the video. Yeah, the argument is that it is false.
Let's hear it.
That it's shown to be false. That you're using globe information.
Yeah, how?
And you're fudging the data.
Right. So the crucial part that matters is
how.
Why do you say it's
go through
false?
the video. Watch the video.
Yeah, this
right.
is
So you
ridiculous,
don't know the argument.
Yeah, I know. Don't watch the video. Get angry at me and ban me.
No, I'm just saying you're going to bring it up. You don't understand the argument. You can't steal me in the argument. But it's like enough evidence for you to reject all the information that goes against your global religion.
If you watch, it's not religion. You have the religion.
Well, you brought it up, man. That's it. I'm just asking you.
No, you brought it up.
You brought up an argument
we don't have an answer.
You don't understand.
Excuse me. You said that we have no arguments for this, and I'm going to show you.
No, you
watch
don't.
the video. They go through this spreadsheet line by line and thoroughly.
What's your argument? What's the argument that
are you
you
going to watch the
understand?
video or not? If you're not going to watch the video, we can stop this argument right now, and you can just pretend that it's not been debunked and not been talked about.
I like how
You know
people
what's
just
funny?
claim
I want to
it.
get that.
This is crazy.
Dude, Beast,
So
you know what's
you're not
funny?
going to watch the video?
You know what's funny is how much he's trolled, and he says like people like only watch YouTube videos as their research, and here he is like, watch the video, watch the video.
Dude,
I understand that.
He
But
watched the
this
video.
I
he
mean,
doesn't even understand
arguing,
and he
but I'm
believes
arguing
it.
on the flat Earth side here. I mean, this is a
You're
YouTube
not.
video, and this apparently YouTube videos are well known on the flat Earth to be the ultimate proof. And here's a YouTube video.
Yeah, but you're not arguing because you don't have an argument. Your
It's not
argument
worth
is
it.
go
Again,
watch
if
something.
you watch the video they go through line by line.
You haven't
Well,
addressed
the thing is, dude, what?
Okay,
Yeah, but what I mean-
I gave you the basic answer. You want to listen to the basic answer one more time?
Yeah, what's
you
the
use
rebuttal?
globe information. You use globe.
How
Stellarium is
How
based
so?
on the globe. The distance to the peak is based on the globe. The height of the peak is based on the globe. And then you go in and adjust the information using formulas that are dubious value. And you come up with an answer. There are certain areas where the globe and the flat Earth both come to the same answer. And it just so happens that you have a couple of them. Now, again, this is all just in great detail in the video. Do you want me to post a link, or you're not going to watch it and I can just go ahead and leave now?
Yeah, if you got a video, post it.
You could actually just go ahead and leave now. Pathetic.
Okay, fine.
Pathetic argument. Yeah, get out of here.
You
Can't
didn't
even
post the
fucking
argument?
back up your own claims. It's been thoroughly debunked. How? Well, you just gotta watch the video. What a
Yeah,
fucking
that's when you know
dummy.
they have no idea what they're talking about. He has absolutely no idea what's in that video. He just liked it because it agreed with him. So now he's going to say, there's an argument out there. I don't understand it, but you need to watch it so you can understand that I'm challenging your argument. But I don't know how I'm challenging it. I'm just going to challenge it.
Yeah, it's ridiculous. Anyway, I'll catch you guys later. That's ridiculous.